All right, let's do it. All right, I'm Olshansky. Uh, I'm the head of protocol at Grove. We're the team that houses uh, we're the company that houses the R&D team for Pocket Network, a decentralized RPC protocol that's been around for a little while now. And I'll go into details of what we do. And what I'm going to be talking about today is modular protocol development. So I used to work at companies like Waymo and Magic Leap and Twitter and Google. And a lot of what I did was MLOps, building infrastructure and local development environments for MLOps and various data scientists. And kind of one of the things I realized is that if they don't have a good local environment, then for every single hour that they waste developing, it's literally hundreds or thousands, if not tens of thousands of dollars that are going down the drain. So as long as the stack of tools that we give them is of high quality, will enable iterative development, agile speed, and the way this extends to protocol development from experience is almost identical. So jumping into it, the typical contributor lifestyle is right here. You find a cool project, you run a local Docker container, you get very excited that it's all going well, but then you start trying to develop locally, and you realize that all of your dependencies are messed up. You eventually just give up and move on, and the cycle repeats as you find a new project. So what we do is we want to move on to the ideal contributor lifecycle. You find a cool project, you run a local development environment, and all of a sudden you can start making changes to the code. You make changes to the code, you implement fixes, you submit the bug, someone reviews it, merges it, and rather than spending half your day fixing dependencies, you're actually going to get going straight away. In the crypto world, this is not that common, especially in protocol R&D, but we fix this, and today I'm going to be telling you about how we did. So what's on the agenda? It's the state of protocol development, a few horror stories of what we've done in the past, some Shannon tooling, and then I'll do a live demo. So, and if there's one question that you should be able to answer leaving today, it's how can we make protocol development more modular? Because we're here at the Modular Summit. And one thing I really want to hone in on as well is that these aren't just software engineering practices. This is real modular. This is very, very specific to developing at the protocol layer. So this is the state of protocol development today. You know, we need good coding practices, but there's a few things that are very, very specific when it comes to building an open source protocol. For example, we got to keep it simple. Like all software engineering needs to be simple. We got to make it even simpler, as simple as possible, but no simpler. We need to be open source friendly. So everything needs to be well documented and have good issues and tooling. But when it comes to being open source and a spec and a protocol that you build on top of, there being open source isn't just important, it's a first-class citizen. There's a few others, but those are kind of the big ones. So what I want to do now is kind of jump into the fun stuff. So this is kind of guess the project. So right here, you can see there's a project with a lot of open source development in the beginning, and then it kind of flattened out, right? That's Ethereum. Another project that kind of had a big jump and then kind of slowed down and came back up, that's the Cosmos SDK. And the last one, I think, is going to be kind of harder to predict. It kind of started off slow and then really picked up at the end. That's the AT protocol, right? It's not even a blockchain, but it is a protocol for an open source social environment. And the thing that's really interesting here is that Solana, for example, only has 500 contributors. Ethereum and Bitcoin have about 1,000. But if you look at the modular protocols, if you look at the Cosmos SDK, if you look at Celestia, they have the same order of magnitude as all of these other protocols, which whose market cap is in the hundreds of billions, while the modular protocols, which are easier to develop on, is very much in the tens. And one of the cool things here is that you can see that Pocket, with the local development environment that I'm about to show you, has really been improving our developer productivity. So just last month in June, it literally went up 400% with a small team of 4 people. And if you put us aside across all the other teams, that's quite an improvement given where we're at. Okay, let's go into some very quick more horror stories because I've seen what chain halts and scalability issues are. Okay, but while listen to us, let's talk about the experience. We have a live protocol that's been live on mainnet for almost 4 years with 1,000 validators, 600 million requests a day, over 800, almost 800 billion requests total over that same lifespan. And we have real products, we have real revenue, we have a real team, we very much pioneered this industry. A few things that happened that kind of led us to want and need to have such a good development environment is our chain halts. So for example, right here, we had a chain halt where there was an indexing transaction issue. Right here, there was an issue of us hitting the scalability issues for Tendermint because it gets capped at 10,000 and we had the 5,000 limit, which not a lot of other teams had. Over there is another one where we literally had a chain halt, waited a day, had another chain halt, waited a day, just as we were trying to release a new feature. This wouldn't happen if we had the local development environment that I'm going to be showing you today. So what I want to show here is that because we're dealing with a protocol and decentralized environments, we can't just restart the servers. We can't just back up the database. We can't just go and look into the validator and see what they're saying. We very much have to have a good environment and testing suite to make sure it just doesn't happen. So what's in the box with Shannon? I'm going to tell you what's in the box with Shannon. Okay, this is what we prioritized. Protocol developer experience, local development environments, end-to-end behavior testing, basically everything that you need in normal software engineering, but customized for a protocol development environment. And this is the big reason why, I really want to do this, is because ecosystem devs, we all care about them. Node operators, they're always having fun and everyone cares about them. Protocol developers, you just assume that it's going to work. You just assume there will be no bugs. You just assume that they're geniuses or hackers or cryptographers that make things work. But no one thinks about giving them the tools they need to succeed. So let me show you what we have. Okay, this is our stack. It's pretty standard. You know, we have Comma BFT, Cosmos ZK, we use Ignite. But the interesting things really come when we say we're not just using Go. I mean, we're using Tilt, which is a local Kubernetes. We're using Helm charts, which a lot of you guys know about. We use RBCD, but we also use Kind to make sure these tools are available locally. We use GitHub Actions. We're trying not to reinvent the wheel. We're using what Cosmos gave us, but we're keeping it as powerful and as simple as possible at the same time. And yeah, you guys, whoever's watching or listening, feel free to take a picture. It'll last longer, and then come and ask more questions if you want to know more about our stack. Okay, so what's in the box with Shannon? We have Tilt. This is basically a local, containerized, Dockerized environment so that you can see all of your actors. You can scale them up, you can scale them down. You can have hot reloading, and you don't even need the internet. Like I will show you in a moment in a live environment how all of this works. And this is what I said. What Tilt enables is a LocalNet where you have logs locally, you have metrics locally, you have bugs locally, you have tests, like literally everything is local. And one of the best parts is it's reproducible. I can make a change, push up a branch, and then later someone else can pull it and mimic the exact same environment themselves. We have manifests. We didn't want to recreate the wheel. So, we were thinking, do we have a UI? Do we have a spec? Screw it. We're just using YAML files. And some of my friends at Netflix, as you know, making their 7-figure salaries a year, just like to call themselves YAML engineers because all they do is update these numbers all day long. We also have end-to-end tests. These are natural language. So literally, you can have a PM that comes in, uses the Cucumber Gherkin syntax, and they can write tests themselves. And engineers can then take that and take an end-to-end user behavior into a true end-to-end test that validates the entire network at once. Observability. We have lots of different graphs, but for the sake of this presentation, I decided to go with the one that has the most colors. So we all like charts, and obviously, but these are actually useful. And the fact that these are updated and testable and usable in a local environment goes a really, really long way. We have a DevNet. Basically, you take that whole LocalNet environment, push it up to a cloud, and that's it. It's very transferable, it's reproducible. Because it's all containerized and Dockerized, it's very, very simple to mimic the same behavior in different environments. And this extends very, very easily into test nets, multiple test nets, and then main nets. Everyone can have their own cloud and see what happens in different environments. So now I'm going to go into a live demo. And before we go into a live demo, I'm going to pray to the sloth gods, because that's I hear that's the latest and greatest religion out there. So let's take a moment. And what I'm going to show you during the demo is kind of how we run tests, how we run a LocalNet, some real world end-to-end usage, and then how we do a PR. So let's do it. Okay, so what I've done is this. I put together this document that I'm going to share with everybody after the fact, where you can pretty much clone the repos and then try it yourself. So what I'm going to do is do a clear and start up a LocalNet. So in order to get that LocalNet I was talking about, I literally just run make LocalNet up. And that's going to be building Docker containers, building protobufs. It's doing a lot of different things. While that's going, what I'm going to show you is we're going to go into another repo. And then if you run make, you can see that we have basically a really nice helper file with all the commands and descriptions for what they do. So these are all part of our make file. So for example, if you ever want to know how to list accounts with Ignite, you can just go into the make file, and here it is. It's the way our team shares a bunch of tips and tricks so that we don't have to memorize everything ourselves, and makes it easier and more reusable. The other thing that I want to show is basically how you run all of our unit tests at once. So I run make go develop and test. Actually, there's a little thing I need to do. This is just an environment issue. But I run make go develop and test, and I'm compiling protobufs, I'm running tests, I'm basically setting everything up so that I can make sure that the LocalNet environment runs well. And while that's going, I did a chef-like thing. So I'm going back to the other tab where you can see that the LocalNet is already running. And if I just press space, right, it tells us, where's the space? Yeah, space to open the browser. Boom. One sec. Here, I press space, and here is that local environment that I was talking about. Everything is in a local Kubernetes Dockerized environment, and you can literally see we have applications, we have a gateway, we have a validator, we have a relay miner, we have our monitoring stack literally all in one spot. And if I just wanted to see, let's say, the dashboard for validators, I literally just click one button from here, and Grafana is available all in the local environment. I can also very easily filter this. And then I can see all the claims, which is a very pocket-specific thing that I won't get into today. So here we are. It's all here. Everything's running. And what I want to do next is show you how this actually happens. So here it is, tilt file. A tilt file is it's what we use for local Kubernetes. It uses Python-like syntax, which I'm not going to go deep into, but we specify Helm resources, and all of those literally just show up here. So you can, as a sage agent, you can filter it. Again, I don't really know anyone else that has achieved this in the past, but the fact that we have this LocalNet environment for testing so quickly is, in my opinion, huge. What I want to do next is scale it, right? So usually you have to provision your environment, modify a bunch of configs if you want to start testing or experimenting in a different way. But what I'm going to do here, just change this. I'll show you guys that we have one app-gate server, one gateway, one relay miner. But I'm literally just going to change all of these to 3. I'm going to save the file. And immediately, the LocalNet environment is scaling to more Dockerized, more pods in my local environment that I can start sending requests through, testing, and load balancing against. So here we have 3 gateways now. We have 3 relay miners, and 3 app-gate servers as well. So what I showed you here is we're still running all of the unit tests after everything compiled in a separate repo. That's this piece. We ran a LocalNet, and we explored a cluster. We can look at logs, and we even have dashboards. Next up, I'm going to show you how to use it. So I already said that we have this fantastic, here, let me move this here. We have this fantastic make file, right? And what if we have, let's see, we have a bunch of send commands. So Pocket's value proposition is decentralized RPC. So what if we do this? Actually, you can see that since not everything is automatable very quickly, what our team did is we used these big, very important statements to remind you to run a command, just to set the environment up a little bit when there's an issue. And now I'm gonna, let's give it a sec, make send relay. There it is. What just happened here? I ran a send relay command, and I ran a REST relay, and I ran a JSON RPC relay. The JSON RPC relay returned a response, and same goes for the REST relay. If we ever wanted to know what actually went into it, it's just a curl command against our infrastructure. So this is an ETH block get number, whereas this is actually a request to a local llama node. So you can see that our local environment mimicked the end-to-end of all of Pocket Network. We have validators, we have applications, we have gateways, we have suppliers. I just span up a local environment that did an end-to-end request, sending a relay, getting a response. And the coolest thing is that the request here is against a llama node that ran an LLM inference prompt on the spot. So this is what we did. We asked it to count from 1 to 10. And let's see, the response we got was, it said it needs more information. That's actually kind of funny. Content, done. Here it is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Whereas that's kind of funny because in a different world, in the previous prompt, it actually said it doesn't have enough information to do the LLM inference. Okay, let's keep going. Now I want to talk about end-to-end tests. So this is running in one tab, and what I'll show you is test E2E. We have something called an E2E relay test. So if we go to the makefile and we search for the end-to-end test relay, we can see that it uses this relay.feature file. And this is something that any product manager, any non-technical individual can do in simple English. So let's say you're let's say you're a designer and you know that the protocol should work in a certain way. Or maybe you're curious, what happens when someone stakes and burns in a specific way that we don't have to get into? You can literally use cucumber gherkin syntax, send it over to the engineering team and ask, is this something you can translate into code? It's not only is it part of your CI/CD, ensuring that it's always going to be kind of stable, but it also extends the ability to have 100% QA to the entire organization. So we don't need to get into the details, but the cool thing is every minor component of the verifiability, like making sure that claims are settled, making sure the request is serviced, this is all part of this natural language process. And like I said, it's done against a fully containerized local environment, so I can even develop when I'm offline. Okay, next up, I want to show hot reloading. So let's just say, let's go down here. We've kind of gone through a few things. Oh, actually, before we do those changes, what I want to show you is an end-to-end test that's not just, so we had one test pass, the other one's a little flaky. But what I'm going to show you now is a full-on stress test where we're going to be stress testing the entire environment in locally. We're going to go back here. We're going to go to the dashboard, opening this up. And we have a few that the team put together. So here it is. We are literally running a stress test. We're running a live load test on the spot. And you can see that we got the number of relay requests is spiking. The number of go routines is spiking. Everything is spiking. Everything is still functioning. But we can understand where are the issues, where are the bottlenecks, where do we need to spend time fixing bugs, while also getting a ton of visibility into what's happening in the network. So there's not much else to show, like unless we start diving into real details. But the fact that I can play around with the dashboards in this real environment, and I mean, all I did is run one command to verify that it works, I think is probably one of the most powerful things I've seen in the development landscape. All right. So what I want to do next is just show how things hot reload. Here's what we're going to do. We're going to open up this file and settled. And I'm going to update this comment, live at Modular Summit. I'm saving it. And while I'm saving it, look, I'm going back to tilt and we can see that it's hot reloading. All I did was save the file. The validator is going to start updating. Everything is updating. Let's give it a moment while it's still compiling. And this way, I don't have to bring down the LocalNet. I don't have to bring up the LocalNet. Everything is just going on its own. So if we go here, settled, and then we run another test, here's what I want to show you. Previously, the comment was settled and expired. Let's actually search this, and expired. Up here, it was the old message, settled and expired claims at a certain block number. Here's the updated message, live in Modular Summit, where we're settling and expiring claims. Since I ran an end-to-end test, the actual claims are going to come in shortly. But the important thing is that this message is updated and I didn't have to do a single thing. Let's give it a sec. Settled one. There might be an issue with the actual claiming process right now. Or maybe I just need to do this. Okay, I'm just gonna keep going through this part, but look, it hard reloaded, and if we had more time, I could just sit down and start debugging this, which is the key thing here. I had a couple slides here in case people had questions around how Pocket works and kind of all the actors that go back and forth, but that was a live demo. Everything is available at dev.pocketroll. Like you can go here, go to developer, and our quick start guide even has a video where I did this in the past, along with all of the instructions and much, much more. It's available at Pocketroll, so like, please do go and check it out. It's a really, really good environment to play around with. But now I want to jump back into the presentation. So let me go into slideshow mode. Okay. So here's the thing. What I just showed you, I think can save not just hundreds, not thousands. I think it can save dozens of hours for every single protocol team on a weekly basis. And of course, we don't want to keep it to ourselves. As engineers, working with engineers, we simply want to share it with the entire community. So what I want to say is how did we get to the point of having such a mature local development environment? All we did was treat protocol developers as the customer, provide a great customer experience, while also being our own customer and building for ourselves. Like when I wake up and I open up my computer to do real work, I am genuinely excited to work on top of the environment that we have. Most engineers like the problem and the product, but here, which is very important, and nothing else matters unless the customer is happy, but here at least you have a good experience, the way you have a good experience having a good coffee, spinning up your local environment without knowing that it's gonna be a pain to start getting going and getting into that iterative state where you can actually add new features or solve bugs or update the dashboards. And I spent a lot of time actually figuring out who I should put on this page. I had all these different companies, I had all these different logos, and at the end of the day, I was like, screw it. I'm actually just gonna go to the Cosmos SDK website, take a screenshot of the front page and put it here. Because as a Cosmos SDK app, what I realized is, we want to bring this back into Cosmos. I think it's a modular environment. You saw that that's what enables a lot of contributors. And I think if we move this back to that environment, we can enable even more developers, and that's going to go a very long way. So no matter how good your tools are, no matter how good the product is, no matter how exciting it is, it's still very important that you have a team and individuals that love what they do. So it does come down to the people. And that's why I want to give a big shout out to the small team that made this happen, right? Ryan, Red One, Dima, H5 Law. These individuals specifically are the ones who contributed to Pocketroll, the name of the current repo. But it's obviously Grove and Pocket who are the ones that helped make it happen, who created the foundation on which the team can build upon. But it's these individuals with whom I, loved making this happen and with whom I want to keep pushing it forward. I mean, there's a bunch of QR codes here. You can scan them, take photos. It's the best way for you to go and try out the local environment yourself. And what I would love is that if you enjoyed it, kind of ping me directly. The most important thing we can do is bring this development environment to the Cosmos SDK. And the moment we do, I think development across the entire ecosystem is going to skyrocket. So That's it. And thank you very much.